Hartzell Propeller leads the industry in composite blade technology. Our composite blades are lightweight, durable, and engineered for cutting-edge performance. Unlike aluminum or wooden blades, they can be restored to their new dimensions over and over again. They're surprisingly easy to repair. This video demonstrates repairs made to a carbon composite blade, specifically on a gouge on the outboard region of the blade. For purposes of demonstration, the blade shown in this video is the Hartzell N7605C. Before you begin your repair, you can find your specific blade model on a sticker on the cylinder of the propeller. For some earlier composites, that sticker will be on the blade. If the blade model isn't obviously identifiable, just check for it on the inspection sheet that came with your prop. Your specific blade model will be identified by the characters after the slash. Hartzell Technical Representative Kevin Ryan has taught countless classes around the globe about the intricacies of composite propeller repair. Today, he'll teach you.
Before we get started, let's look at some of the tools and materials you're going to need to perform a repair on a carbon blade. You'll need the carbon fiber repair material, a coin tapper, a sanding block and sandpaper, some vacuum bag material, a piece of 20,000 safety wire, a steel rule, a marker, some clean lint-free rags. In this case, we're using cheesecloth. Please do not use these commercially available shop rags. They are oily and they can damage your repair. The adhesive, a tape measure, a scissors, a supply of acid brushes, a rotary tool or die grinder, some solvent. In this case, we're using denatured alcohol. You can also use MEK or acetone. Some spreader plates, thin, flexible spreader plates. Some of these are masonite. A roll of tape, the appropriate colors of touch-up paint, a DA sander, and a dust mask, and a pair of safety glasses.
Before beginning any repair, you'll need to reference the Hartzell Composite Propeller Blade Field Maintenance and Minor Repair Manual. It's more simply identified as Hartzell Manual 170. You'll find Manual 170 on our website. Just type in hartzellprop.com/Manual 170 and the PDF document will download to your computer. Once Manual 170 is open, first click on the chapter entitled Inspection Procedures in the left margin. Under the list of figures, find the link that identifies your prop. In this case, since we have an N7605C blade, we know it's listed as an N-shank blade. Click on figure 1.3. Here you'll see a graphic of your blade. In order to properly assess the gouge, we need to determine whether it's on the outboard or inboard region of the blade. You'll see here that distance Z is the length of what is considered the outboard region of the blade. Look at the chart below and you'll see that for our blade, that distance Z is 18.43 inches.
So we'll take a quick measurement from the tip and we'll see that that gouge is somewhere in the neighborhood of 13.5 inches. So it's on the outboard portion of the blade. So we'll use that repair scheme to determine the repairability of this blade.
Now, when you return to the manual, navigate to the chapter called Damage Evaluation. When you click on the title in the left margin, you'll see a list of nearly 36 kinds of blade repair. Our type of damage is considered a gouge or loss of composite material on the outboard region of the blade. In this case, number 21 on the list. Click on the link and you'll see this chart. Locate the model N7605C on the vertical grid and follow it down to the horizontal grid for line 21. You'll see the X where line 21 intersects with the 7605C blade is line 21 limits 1. Now click on Repair Limits in the left margin and then click on 21 limits 1. And you'll end up at this table that will tell you whether your damage falls within the airworthy limits of the prop. There are two important things to note here. Notice under the limits designation, it says, do not include the paint while measuring the depth of a gouge or loss of composite material. so we need to remove the layers of paint before we measure our gouge. Also, the maximum permitted diameter, or equivalent area of a gouge or loss of material, is 500 thousandths of an inch. The maximum permitted length of a gouge or loss of composite material is 2.5 inches long, and the maximum permitted depth of a gouge or loss of materials is 20 thousandths of an inch. These depth and length restrictions will help us determine whether this blade is repairable. If your specifications fall below the measurements in this table, your blade can be repaired, and you'll be directed to Section 4A for those instructions, the same that you'll see in this video. If the measurements exceed these measurements, a major repair may be necessary, which would have to be performed either at a propeller shop or here at Hartzell. You may notice throughout this video that other parts of the propeller blade will be shown in various stages of repair, like this and this. That's because this video was taken over a period of time when we were also creating videos for other blade repairs on 2 other sections of the blade. Of course, none of this affects the repair that we're focusing on here. It's just a simple note for your reference as we continue through the repair process.
So the first thing we're going to want to do is to remove this paint to determine the extent of the damage. What I have here is a sanding block with some 80 grit sandpaper on it. You can use a little lighter sandpaper if you'd like to, especially if it's your first time. But I'm just going to take this sanding block and I'm going to sand this paint off so I can further assess the damage. When you're sanding, resist the temptation to wipe away the dust with your hand. On the carbon blades especially, the carbon blades tend to splinter a little bit in the damaged area, and you'll end up with a carbon splinter in your thumb or your hand or whatever, and it's very painful. And in spite of knowing exactly not to do it, I do it almost every time I work on one of these blades.
It's important at this stage that you make sure your damage falls within the airworthiness limits and repair limits of your blade. You'll recall that to fall within those limits, this gouge must be less than 2.5 inches in length and no greater than 20 thousandths of an inch deep. While our gouge is obviously less than 2.5 inches long, measuring depth can be a challenge. To overcome that obstacle, let's watch this tip from one of Kevin's similar repairs on a Kevlar blade.
Because this gouge is so small and so narrow, it can be difficult to get a type of a tool inside the gouge to assess the depth. But every aviation shop has 20 thousandths safety wire. You're allowed 20 thousandths depth of the damage. See if the piece of safety wire will go into the gouge. If the gouge is deeper than the wire, it's deeper than 20 thousandths. But if it's above the gouge, it's not 20 thousandths. You don't know exactly how deep it is, but you know it's less than 20 thousandths in depth. So we just put the wire in there, and this has very, very little depth at all. If it appears that it may be deeper than the wire, you can stick the wire in the gouge and take your steel straight edge and put it on the wire and see if it rocks or if there's a gap between the wire and the blade. If there is, it's not 20 thousandths deep.
Again, if your measurements exceed either the repair limits or airworthiness limits for this blade, you'll need to get professional help.
To repair this gouge, I'll want to sand down to the bottom of the gouge, and then I'll want to bevel out away from the repair approximately 1/2 inch. So to make that a little easier for me while I'm preparing the blade for repair, I'm going to make some marks 1/2 inch away from the repair, from the gouge, and draw a circle around it so I know where my bevel should end. Sort of connect the dots here. So I'll start in the center where the gouge is. I'll work to the bottom of that gouge, and then I'll taper it out to the area I've outlined. With the carbon material, you want to proceed with caution because the carbon material does tend to sand out rather rapidly. And if you've done other composite repairs before, say for example on fiberglass or Kevlar blades, the carbon material seems to remove much easier than the Kevlar or fiberglass. To perform this repair, we're going to need to cut 2 pieces of carbon. One of the pieces is going to be small in the low part of the repaired area where the gouge was originally. It's difficult to tell on these carbon blades exactly where that area is. So often you can determine where that area is by wiping the area with the solvent. And it will help you to determine by the weave of the fabric where that low area is. It's right there in the center, right here where my finger's touching. What I'm going to do quickly while the solvent's still wet is put a piece of vacuum bag material over and look at that, circle that small area, and then I'm going to make another larger circle where my beveled area was. Then I'll use this as a template to cut out my repair materials. You always want to cut out your repair materials prior to mixing the adhesive. The adhesive has a very short pot life, it's about an hour. So if you have multiple repairs you need to make, you should make your templates and cut out your repair materials prior to mixing the adhesive. This is the template that I made for the gouge on the N7605C blade, the carbon fiber blade. And this is the carbon fiber repair material. So what I'm going to do here is I'm going to lay this template down on the carbon fiber, and then I'll cut that out. Notice that I've got the template piece is somewhat oblong, so I've got that running the same orientation as the this way on the weave. When I go to cut the second piece, I'm going to cant the part a little bit, so my next piece will be at a 45-degree angle roughly to the original piece that I cut out. So I cut this first piece, weave this way. So I'll turn my template roughly 45 degrees and I'll cut out my second layer.
Manual 170 contains suggestions for the type of adhesive you'll need to continue your repair. Typically, the adhesive is created by mixing 2 separate components by weight. In this case, we mix 100 parts of Part A to 33 parts of Part B. While you may buy quart kits like we use at Hartzell, it'll likely contain more than you'll need for your small repair. That's why you can also buy more economical, smaller portions from Hartzell, like a 50-gram pudding cup. In these packs, the parts are already pre-measured. You simply mix one into the other. Or there are easy packs, which feature 2 components divided by a plastic separator. When you pull out the separator, the materials mix in the bag.
Before we get started on this repair, I want to make sure the repair area is clean. So I'm going to wipe it off with alcohol. Make sure it's dry before I put on the adhesive. I'm going to apply the adhesive to the repair area and the surrounding area. I'm going to take my first piece, my small piece, the bottom of my hole, the gouge, place that there, and I'll make sure that that piece is thoroughly saturated with the adhesive. Then I'll apply my top piece. And make certain that that's saturated with adhesive. Finally, I'm going to cover this area with another piece of carbon cloth. Now this piece of carbon cloth I didn't cut to size or worry about stair-step pattern. It's just going to be sort of a sacrificial layer. I'm just going to put this on here, and then when we go to sand the repair off, most of that material will get sanded off, and it will just help blend the repaired area into the rest of the blade surface. It's usually not even necessary to put adhesive on this, but I'll add a little bit onto it because it looks a little dry. I'm going to cover the repair with a piece of vacuum bag. And then I'm going to cover that repair with a semi-rigid plate. This is actually an auto body filler spreader. And I like to use these on these types of repairs because they are flexible enough to conform to the camber of the blade. So if you're working on the camber side of the blade, these are nice to have, and they're readily attainable. Because this is in the center of the blade, it's difficult to reach with a clamp, so I'm just going to tape it in place. Just hold that in place. The adhesive is cured. It takes 12 hours at room temperature for it to cure. So we're going to remove our tape and spreader plates and see how our repair came out. That repair looks good. We're going to sand out this gouged repaired area. The adhesive, the excess adhesive on the outside here needs to be removed, and most of this outside top piece will come off when I sand it off. As I mentioned when I laid it on there, that's simply a sacrificial layer to fare the material into the repair into the remainder of the blade. I'm going to use a sander with 150 grit sandpaper. You can go a little lighter sandpaper if you'd like. This carbon material seems to sand out a little faster than, say, the fiberglass material. So if you haven't used it before, if you haven't done it before, it's better to start out slower with a lighter grade of paper and then move up as you start feeling a little bit more comfortable. Once I get this sanded out a little bit, and I'm getting near the end of my sanding, I'm going to switch over to hand sanding and just do any final touch-up by hand. Now that we've got the repaired area sanded off, we're going to use the coin tap again and just assure that the repair that we've made was sound. So tap the repaired area. No dead spots, that's a good repair. Well, we've done some significant repairs to this side of the blade, and while in theory we could just paint this area or just paint this area, it's really not going to look very well. So it's probably in our best interest just to paint the blade as a whole. So what I'm going to do is I'm going to use the 400 grit sandpaper. I'm going to lightly sand the area, rough up the paint surface. Notice also that I've masked off all the areas I don't want to paint. The leading edge, my tip stripes, and the de-ice boot, anti-ice boot, or if neither an anti-ice boot or a de-ice boot are installed, there'll be a piece of erosion tape there, and that needs to be masked as well. So I've masked all this off, I've masked off the hub, so I'm just going to scuff up the paint and then paint it. I'm going to use 400 grit sandpaper and just lightly then I'll tack off the dust with my lint-free cloth and the alcohol. I'm going to spray the entire blade using the black touch-up paint. This is a product that is canned up for Hartzell. There's also a commercially available spray paint that you can purchase on the internet. You can also use the regular specified epoxy paint that we use in production or is used in an overhaul shop. You wouldn't necessarily have to use this touch-up paint. So, once again, we're going to start out spraying slowly, carefully, avoiding runs, and it's going to take more than one coat. A few more coats, this will look good as new. Thanks for watching this video. I hope it's done something to dispel some of the fears you may have had about working on composite bladed propellers. As you can see, the repairs aren't particularly difficult, and with a little bit of practice, you can perform them in your shop. And if you happen to run into trouble, you can always give us a call here at Hartzell or send us an email. Thanks again for watching.
For more information about Hartzell Composite Propeller repairs, we invite you to contact Hartzell Product Support. Call 800-942-7767 and then option number 3. Or visit us online at hartzellprop.com.